Greetings to you. Welcome to Physics with Ben. My name is Okuma Benjamin. In today's video, we'll be looking at how to determine the value of oscillation due to gravity using the simple pendulum. So, this is determination of the value of acceleration due to gravity. Small g, also known as the acceleration of free fall. There are so many simple experiments in physics that are very, very interesting. They are simple, but the results they give are very, very amazing. So in this video, I am going to teach you how to determine the value of acceleration due to gravity. The value is given as g is equals to 10 meters per second square, or g is equals to 9.8 meters per second square. One thing you will know about this value is that I always tell my students g is not a constant, meaning the value of g varies across the Earth's surface. If you find the value of g right now where I'm standing at the basement of this building, if you go up this building, the value of g will decrease. And the higher you go up, that is the farther away your distance is from the center of the Earth, the value of g will also be decreasing. So the equation we need for this experiment is given as t is equals to 2 pi root L all over g, where t is the period of oscillation in seconds and L is the length of the thread in cm, and we are going to convert that to meters, and g is the value of acceleration due to gravity which we want to look for in this experiment. The apparatus needed in the experiment, we already have our thread here with us, the pendulum bulb. As you can see, there's a white lever in here. That is the center of the bulb. That is where we are going to take the reference of our reading from. And then, of course, the rotor stand. We place this block here so as to give us a rigid support. We need a stopwatch for this experiment. We need a meter rule. If you have not seen a meter rule before, this is what we call the meter rule. It is called the meter rule because here you have 100 cm. So the parameters we need to measure right now, we are going to measure the length of the thread, and we are going to use n. N means the number of complete oscillations. To get more accurate results, we are going to use our n to be 20 complete oscillations. Of course, you know what that means. If we use a lower value, we are going to get some errors in the experiment. And so we are going to use this equation as well. T is equals to, that is period t, given as time taken all over number of complete oscillations. Time taken is period t is equal to time taken all over the number of complete oscillations. Of course, we also find the period of oscillation, the frequency of oscillation of this bulb. And the frequency f is given as n all over t. And that is why we always have our t to be equal to 1 all over f, and our f is equal to 1 all over t. So we are going to make use of all these equations. So for the time being, we are going to measure the length of the thread. So let's begin. This is the thread and the bulb. So our measurement, we start from the 0 reading of the meter rule down to where we stop. So we're going to choose any value of the length we want. We may go with 50, 60, 70. So for the sake of this video, we want to go with 60. 60 is somewhere here. So I will pull this down. Yeah, I will pull this down, and to avoid error due to parallax, I would love to bend down so that I will look at the reading this way. So my ruler is facing this way now. This is, I'll have to take it up a little bit. This is how you are supposed to sit in your experiment. So this is exactly 60. The length of the thread, the reference point is this point, and this is exactly 60. You can see where I'm putting the meter rule. This is 60. So if you turn around, this is what you have. You see that? This is it. What do you see? That is 60. So the length of the thread is 60 from this point to that point. So now that we are done measuring the length of the thread, we are going to oscillate this bulb for a number of 20 complete oscillations. And we are going to time. The time in here is not the t. We are going to find t, small t, for 20 complete oscillations. As you can see, our stopwatch is reading 0, 0, 0. And so, what do we mean by one complete oscillation? If this bulb is displaced and it goes this way and come back this way, that is one complete oscillation. That is to and fro. That is 1, 2. 1, to go back and confront. We call it one complete oscillation. I'll do that again. The bulb will be displaced. It will go this way and come back this way. That is one complete oscillation. For us to get accurate reading in this experiment as well, we need to close all the air source to avoid air interference. If we don't take consideration of all these factors, by the end of the day, we are not going to get the value of G as predicted on the board here. One thing you need to know again is that anytime we are giving an experiment, we want to run an experiment in physics, what we are trying to do is that we want to verify what we already have on ground. The textbooks and scientists have made us to understand that the value of G is 9.8 meters per second square or 10 meters per second square. So is this value true or false? Our experiment is what we tell if this is true or not. So we want to verify and know that G is actually this value. And one thing I also want to know is that the equations in physics, the experiment and the theories, they all speak one voice, the voice of truth. Experiment, theory, and equations, they all say one thing. It means that if you are performing any experiment that is accurate, the theory must agree with the equations. The theory and the equations must agree with the experiment. If not, what you have done is wrong. Again, from what you can see on the board, in this experiment, there's a trend in this experiment. The trend is the trend between the period t, and the length of the thread. The period T and the length of the thread, they have what we call direct relationship. They are directly related to each other, meaning when the length of the thread increases, the period T will increase. When the length of the thread increases, the period for one complete oscillation will also increase. We call it an increase trend. Such a trend will give you a straight line graph passing through the origin. Now, before we run this experiment, I want us to define some terms. Period T of oscillation. What do you mean by the period of oscillation? The period T of a body performing simple harmonic motion is defined as the number of complete, as what? As the time taken, it's defined as the time taken to make one complete oscillation. Look at it on the board here. As the time taken to make one complete oscillation. The period T of a body performing simple harmonic motion is defined as the time taken, small t, to make one complete oscillation. The frequency of oscillation is defined as the number of complete oscillation per time, or let's say the number of complete oscillation per unit time. And the relationship between period and frequency is what you see on the board. It is an increase-decrease trend, meaning when the frequency of oscillation increases, the period of oscillation will decrease, and vice versa. Here also, when the period of oscillation increases, the frequency will decrease, meaning if this bulb is oscillating very fast, the time taken to make one complete oscillation will also decrease. And that can only happen when the length of the thread is shortened. So it is time for us to perform our experiment right now. So as I said, the bulb will go this way and come back this way. That is one complete oscillation. So let us time it together. Here we go. By the way, before we start again, you must not displace this bulb at a very large angle. Should you do that, you will have an error in your experiment. You will have what is called conical oscillation. So to avoid conical oscillation, we are advised to displace the bulb at a very small angle. Do you get it? So let's start. So I am bringing this thread back. The length of our thread, L, is given to be, the length of the thread L is given to be 60.00 cm. And we want to find the time taken for 20 complete oscillations. And then we'll come back to this equation and substitute and get the value of G. So let's start. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Our time check is 31 seconds. So we are going to find T1, T2. So T1 is what? 31.00 seconds. We are going to find this. Run it 2 times to get our average T. Our T is T2 plus T1. T1 plus T2 divided by 2. That is the average T. So we are going to find T2 again so that we get accurate results. So we reset our stopwatch and do it again for the second time. Back to 0, 0. Okay, are we good? 1, 2, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We got 31.03. 31.03 seconds. So our T is 30.00 plus 31.03 divided by 2. Our answer is roughly 31 seconds. Let's try that and see what we get. So you just need your calculator to have 31 plus 31.03, that is 62. We have 62.03 divided by 2. Divide by 2. So the time taken T for 20 complete oscillations is given as 31.015. 31.015. So I am going to clean all this so that we'll have time for the calculations. I believe I would love if you can screenshot this quickly because I'm cleaning it right now. So I'll clean this so that we'll have time for the calculations. So right now we have two parameters on the board. T, the time taken for 20 complete oscillation, small t, is given as 31.015 seconds. So now that we have gotten our T, it is not a small t that we are using. We have L as 60, L is there. We have T from this equation now. T is small t over N. So what do we do? So from T is equal to small t over N. T is equal to small t. Small t is 31.015 divided by N. Our N is 20 complete oscillations. So we'll have this divided by 20. So our T, which is the period of oscillation, is given to be 31.015 divided by 20. Sorry, 31.015 divided by 20. Our period for 20 complete oscillation is given as T equals to 1.55075. Let's leave it to 2 dp. So our T is approximately 1.55 seconds. You see that? This is your small t and this is your period. So from here you can equally find your frequency. The frequency of oscillation is given as your F is equals to 1 all over T. So this implies that your F is equals to your F is equals to, I'm sorry, I'm done with this. I can take this away from here. I am done with the experiment so that I will have time to solve on the board. So your F is given as 1 all over 1.55. Your answer is supposed to be 1 divided by that. Your frequency of oscillation is given as 0.64 Hz. The frequency with which the pendulum board was oscillating or vibrating with is 0.64 Hz. But that is not what we are here for. We want to find the value of acceleration due to gravity. So I have gotten this value. I'm free to clean this from here and write as my T is equal to 1.55 seconds. So that is that for that. Now, from this equation I have written down here, we are going to make small g the subject of the formula. Very, very simple. We are going to make small g the subject of the formula. So from here, let's start. We have given that your t is equals to 2 pi root L all over G. Divide both sides by 2 pi. Your T all over 2 pi is equals to 2 pi root L over G divided by what? 2 pi. This will go. So you're having your T all over 2 pi is given as what? Root L all over G. We are going to square both sides. We are going to square both sides. And if we do that, this will cancel this. And so you are having your T square all over 2 square will give you 4. Pi square will give you pi square. So you are having T square divided by 4 pi square is equals to L all over G. If you cross multiply, you are having 4 pi square L is equals to T square G. We want to make small g the subject of the formula. So what do? We divide both sides, or you flip the equation. This also implies that T square G is equal to 4 pi square L. So we divide both sides by T square. So divide both sides by T square. This will cancel this. And your G is equal to 4 pi square L all over T square. At this point, we are going to substitute. We are going to use the value for pi as 3.142. The value for pi is given as 3.142 or 22 all over 7. But we are going to make use of this value. So I will come back and claim, mind you, this equation we use. T is equal to 2 pi root L all over G. So I am free to claim this section of the notes now. So if G is this, you can call this equation star. So your G is given as 4 times or 4 into 4 open brackets 3.142, you square this, times L. Mind you, we are not going to use 60.00 cm. We are going to convert cm to meters. And so what you have here, you have 60 divided by 100. That will give you 0.60, about 60 divided by 100. Yes, I was correct. We give you 0.6 meters. That is the value we are going to use. So you have your G to be here and your 4 to be here. Your pi is 3.142 square times L. Your L is what? Your L is 0.6. Your L is 0.6 divided by what? T square. What is your T square? Your T is 1.55. So divided by 1.55, you square this value. So if we evaluate correctly, what do we have? I believe you are there with your calculators. Okay, let's do it again. So let's do. We have G is equals to 4 times. We have 3.142. 3.142, you square that value, what do you have? You have 9.872 times 0.6 divided by 1.55 square. What do you have? You have 2.4025. Let's evaluate the top. So we have 4 times 9.872. 4 times 9.872 times 0.6. We have 23.6928 divided by 2.4025. If you do that, you're going to have 23.6928 divided by 2.4025 divided by 2.4025. Oh my God! So we have 9.86. Exactly what was predicted. We have 9.8617. What is the unit? Meters per second square. Meters per second square. How do you get that unit from? Length is measured in meters. Let me write it out correctly. So you have your G to be equals to 4 pi square L all over T square. So the period T, dimensionally, the length of the thread is measured in meters and T in seconds. So you have seconds square. So the unit for G is meters per second square. So to write this value to 2 dp, we have therefore, acceleration due to gravity in Matter Ecclesial College is given as what? 9 points. Let's say 9.9. 9.9 meters per second square. I told you this constant is not a constant because it varies across the surface of the earth. I want to comment quickly on this result. So approximately your G is what? 10 meters per second square. The reason why a good number of students fail questions on mechanics, especially the simple pendulum experiments, some group of students are good in copying results on the internet. please, I want you to pause. I want you to stop whatever you are doing and pay maximum attention. I am speaking as one that has also been privileged to mark WAEC, and we know some of these things. Now, if I run this experiment, let's suppose in the north, and I get this value, do you get it? And then I quickly forward my result to someone who's writing this experiment in Lagos or Delta State. The person will not get accurate results. At the end of the day, there's what we call accuracy. If the examiners go through it and discover that there is too much variation, too much differences from what the student have gotten with what the teacher has gotten, the examiners may decide to mark that center down. So please, this value is peculiar for a particular environment. For where I am standing right now, which is in Lagos, this experiment is performed in this physics lab, as we're seeing here. For this particular value, this is what we have for G in this lab. If I go upstairs and run this experiment, I am not going to get the same results. Do you get it? God bless you. So this is how to determine the value of associated due to gravity using this equation and also the simple pendulum experiments. One thing I want to quickly comment is the angular frequency or the angular velocity. You know that omega is equal to 2 pi f. And recall that we got the value of f. And you also know that f means 1 all over t. So from this equation, we can simply, and so the angular velocity as was calculated is this. Omega, from here we have omega is 2 pi f, and f is 1 over t, and we did that, we arrived at this equation, we substituted, and then we got this. So to this we have come to the end of this video. Thanks for your time and remain blessed. I would love if you can help me share this video so that this YouTube channel will have more patronage. From time to time I'll be producing videos on past wire questions on mechanics, electricity and optics. Help me make this channel grow so that both of us will benefit from it. If you have any WAEC student around you or candidates around you, just invite the person to subscribe to this page and also share the link. God bless you. It was nice having time with you. Bye-bye.